So hello student. So today I am studying a new topic, Millman's theorem. I hope you all are well. Okay. So today I am studying your Millman's theorem. Okay. At first I am say that this theorem is as like Thevenin theorem. As like Thevenin theorem. Why? Because I am taking one example. Okay. At first I am taking. At first you note down a key point. What is the key point? The key point is write down the key point in this theorem as like Thevenin theorem. This theorem is same as Thevenin theorem. Okay, write down this thing. This is a key point. Okay, now I am starting Millman's theorem. Actually, what state Millman's theorem? If any circuit containing more number of sources, then we apply Millman's theorem. This is the easier way to solution any circuit where more sources are connected. Suppose the circuit is like this type. Okay. Like that. Dot. Okay. Here the load resistance will connect it. This is called RM. Okay. Suppose this type of network you have, and the question is that find the load current. Okay. Then how to solve this type of problem? So what is the question? Question is that find the load current. What is the question? Find the load current. So this type of problem, I am solving this type of problem using Millman's theorem. Suppose this is the R1, this is the R2, this is the R3, this is the R4, R5, Rn, same as V1, V2, V3, V4, V5, V6. Okay. So sorry, this is the Rn. N number of resistance and n number of voltage source are connected in this manner. Okay, connected in this manner. So how to solve? If I am converting this circuit, if I am able to convert this circuit into a Thevenin circuit, then the problem is more easier. If I am finding the VTH from this circuit, or this voltage is also called equivalent voltage of all the voltage sources. This voltage is also called the equivalent voltage, VEQ. Okay. And if I am find the R equivalent or RTH, same as RTH, and we know the load resistance RL. If I am able to convert this circuit into this circuit, then only this is a more easier for us. Okay. So how to convert? At first I am solve this circuit, and from this circuit, from A Suppose this is our main circuit. From this main circuit, I am find the VTH and RTH. So how to calculate? Okay, how to calculate? Note down all the point. Okay, everyone. At first, I am find okay. At first, I am modified the main circuit. Okay, what is the modification? If I am shorted the AB terminal, so what is the AB terminal? This is our AB terminal, A and B terminal. Okay, this is our A and B terminal. If I am shorted the AB terminal, then I will get what? Okay, write down. If I am shorted, write down. Shorted the AB terminal, then what is the circuit? The circuit is modified. The RL is removed here and this terminal is shorted. If this is a shorted, the current flow through the short circuit terminal is called ISC, short circuit current. Okay, so what is the value of ISC? The ISC is equal to I1 plus I2 plus I3 plus I4 plus I5 dot IN dot IN. Okay, write down this manner. Write dot IN. So what is I1, I2? This is I1, I2, I3, I4, I5. This also IN. Okay. If I am sum all the current, okay, because this is a parallel connection, the current are coming. If this is I1, I2, I3, I4, I5, and IN, the summation of current flow through the ISC. Okay. So that's why you can write down ISC equal to I1 plus I2 plus I3 and I4, I5 dot IN. Okay. Now I am find the R equivalent of the circuit. Okay. So what is the value of R equivalent of this circuit? The R equivalent is, what is the value of R equivalent? The R equivalent is 1 by R1 because this is a parallel circuit. So 1 by R1, 1 by R2, 1 by R3, 1 by R4, 1 by R5 dot 1 by Rn. Okay, 1 by Rn. So if I am write down this manner the equivalent resistance, so actually this R equivalent is 1 by R equivalent. Okay, 1 by R equivalent. In a parallel circuit, more than 2 resistors are connected in parallel, then I am solving this way, only this way, 1 by R1, 1 by R2. If 2 resistors are connected in parallel, then only you can solve multiplication by R1 into R2 divided by R1 plus R2, multiplication by summation. Okay. If more than 2 resistors are connected in parallel, then only you can solve this way. Okay. Okay. Now, what is the value of V equivalent or VTH? What is the value of V equivalent? The value of V equivalent is V1 by R1 means I1. What is the value of V equivalent? Current by R equivalent. equivalent? I think what is the current? The current is short circuit current divided by equivalent resistance. Short circuit current divided by equivalent resistance. So what is the value of short circuit current? The short circuit current is I1 plus I2 plus I3 I4 I5. So at first you write down I1 plus I2 I3 I4 I5 dot I10. Then you can write R equivalent 1 by R equivalent. Okay, 1 by R equivalent. Okay, now put the value of I1, I2, I3 and I4, I5, In. Now I am clean this. Okay, this area. Okay, so what is the value of V equivalent? V equivalent is I1 means V1 by R1, V2 by R2, V3 by R3, V4 by R4, V5 by R5 dot V equivalent by here V equivalent. This is the Vn by Rn. Okay. What is the R equivalent value? 1 by R1 plus 1 by R2, 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, R5, 1 by Rn. Okay, so this is our V equivalent. Okay, now we get V equivalent value. That means this, and R equivalent means this. If I get these two values, then easily you can solve the value of load current. So what is the load current? So the IL is V by R, where V means V equivalent divided by R equivalent plus RL. Okay, so this is our Millman's theorem. Okay, so I am taking one problem, one example. Okay, I am taking one example. Write down each step in your copy. Okay, otherwise you can't understand. Okay, so the problem is that try to solve this type of problem, okay, through Millman's theorem. This is not so much important in semester exam and also, but in grade exam or any other exam, if you able to solve through Millman's theorem this type of problem, the time consuming is so short. Your time is reduced. Okay. This is one great problem. So what is the value? What is the value of I? So what is the value of I? At first I will convert this circuit into Thevenin circuit. In Thevenin circuit we need VTH or V equivalent and R equivalent. Okay. So how to solve? So V equivalent is V equivalent equal to V1 by R1, V2 by R2, V3 by R3. Okay? Okay. Oh, sorry. This polarity is opposite polarity. This is a minus and this is a plus. Okay. This is a minus and this is a plus. That means 12 by 6 minus 12 by 12 plus 12 by 14 plus 12 by 14. Sorry, this is not a 14, this is a 4. Okay, this is a 4. So why is a minus? Because the polarity is opposite. Okay, now 1 by R1 means 6 plus 1 by R2 means 12, 1 by R3 means 4. Okay, 1 by R1, 1 by R2, 1 by R3. Now solve. If I am solving this equation, we get 2, 1, 3. 2 minus 1, 1, 3 plus 1, that means 4. Okay? And this is a 12, 6, 2 plus 1, 4, 3. Okay. 4 into 12 by 6 is 8 volt. Okay. The V equivalent is 8 volt. I think understand all of you. Okay. Now write down the value of. So what is the R equivalent? Here R equivalent is this 12. That means 6 by 12. That means 2. Okay. The R equivalent is 2. So what is the value of current? The circuit is Thevenin circuit. This is a V equivalent 8 volt. R equivalent 2. Load resistance 4. So what is the value of current? I equal to V by R. V equivalent by R means 4 plus 2, 6, and V equivalent is 8. 8 by 6, that means 4 by 3. Okay, this is our answer. Ampere. So what is the procedure of Millman's theorem? If I am seeing any circuit in this manner, that means more number of voltage sources are connected through parallel with the resistance and this manner. So this type of problem I am solving through Millman's theorem. Okay, Millman said that if you convert this circuit into a Thevenin circuit, then it solves the load current or load power or load voltage, whatever. Okay, so how to convert? At first I am taking the V equivalent, then we find R equivalent and put down the value and find the current. Okay, okay, this is also easier. Okay, now I am taking one AC circuit. For AC circuit, how to solve? If I am taking one AC circuit, same. No difference. Okay. For AC circuit it is also same. Resistance, there are also a voltage source, but the voltage source is AC. Resistance, voltage source, sorry, this is the impedance, okay, not a resistance. For a dot and one load is connected. So whatever the load, I am taking impedance load. Okay. So what is the value of impedance? Z1, Z2, Z3, Zn, Vn, V3, V2, Z1. This is the Zn, load impedance. Okay. If this type of problem given, then you solve through Millman's theorem. I have to solve 1 by Z equivalent. 1 by Z equivalent equal to what? 7. 1 by Z1 plus 1 by Z2 plus 1 by Z3 dot 1 by Zn. Okay. How we can solve? I will convert this circuit into a Thevenin equivalent circuit. Okay, this is the voltage, this is the equivalent impedance, and this is the RL load. That means RL, Z equivalent, and this is V equivalent. Okay. If I am find Z equivalent, V equivalent, and ZL, then we can solve easily. Okay. What is the value of V equivalent? V means I into R. Okay. And write down I. Here I is ISC. That means short circuit current. If I am short these two terminals, same as A and B. I am taking these two terminals A and B. If I am shorted these two terminals A and B, then we get, if I am short these two terminals, then we get short circuit current. That means V equivalent means ISC by 1 by Z equivalent. Same thing. Okay. So write only now, write down the value of ISC. So what is the value of ISC? I1, I2, I3, IN, and if I am shorted this terminal, then we get the ISC. Okay? So what is the value? ISC, I1, I2, I3, IN. Okay, and what is the value of Z equivalent? 1 by Z1 plus 1 by Z2, 1 by Z1 plus 1 by Z2 plus 1 by Z3 plus 1 by Zn. I think understood all of you. If you have any problem, then ask me. Okay, no issue. Now put the value of I1. Now put the value of I1. So what is the value of I1? I1 means V1 by Z1. V1 by Z1, V2 by Z2, V3 by Z3 plus dot Vn by Zn. Okay? Vn by Zn. So V1 by Z1, V2 by Z2, V3 by Z3 plus Vn by Zn. Now put the value of 1 by Z1 plus 1 by Z2 plus 1 the IL. So what is the value of IL? The value of IL is IL equal to V equivalent by Z equivalent plus ZL. Okay, I think clear for all of you. Okay, put the value and you get the answer. If the question is that find the load power, find the power distribution through the load resistance, then what happens? The PL equal to IL square into ZL. If the question is that find the voltage drop through the load, voltage drop, that means VL equal to voltage across the load resistance IL into ZL. Okay, if I am find IL, then this problem is more easier to find power and voltage drop across the load. Okay, so thank you class.